In this video, we're going to be changing up how our door actually rotates. So if you recall currently, well from the previous video, it just snaps open and closed like so. Well, we're going to make it so it has a smooth transition that clients can see. So it's going to take some time. Instead of being a snap, it's going to actually rotate as if it was naturally kind of opening, I guess is a way to put it. So that'll be quite simple to do. The only thing we are going to have to do is go to we can view the Kismet library, and you can see all their functions here. And here's where we can kind of determine how you want it to open. So I'm actually remove the highlighting so it's easier to see. So our interp2 is pretty much interpolation for rotation. So this will, if we use this, we can have it rotate, and it'll start out slow and speed up towards the halfway point, and then it'll end slowly. So it'll be kind of like a slow push open, fast, and slow again as it finishes its rotation. Whereas this will be a constant speed. So this is where you can choose kind of which one you want to use. So for me, I kind of like the look of just the normal rotation or the normal non-constant, as it just kind of looks nice. It's just a little different. So you can see the parameters. It takes in the current rotation, the target rotation we want to make it go to, delta time, and then the speed in which we want to have it rotate. So this is where we're going to tinker around with both the speed and our timers. So we may need to increase the rate at which our timer runs. So let's go ahead and go to wherever I need to include the header, right there at the top, and we are ready to get started. So go to our rotate door, and here we can I'm just going to go ahead and get our active rotation and F rotator, current rotation, just to make it a little bit cleaner to see. And let's remove our pausing of the timers. So now you can see what it returns. It returns a rotator. So it's essentially going to return the new rotation that it gets from calculating between all of this. So we're going to store that. So F rotator, call it new rotation. It's going to U Kismet math library, R interp2, and then we take our parameters. So obviously it's going to be our current rotation. Then our target rotation is going to be open rotation. And then we have our delta time. So to get our delta time, we do get world, get delta seconds, and then our interp speed. So we'll just do 0.1 for now and see what that gives us. And then we can simply set the rotation. So this set actor rotation, new rotation, just like so. We're going to do the exact same thing for our door closing, except this is open rotation to closed rotation, just like so. And this should at least give us a general idea. We don't have a way to stop the timer yet, but we should be able to see the door roughly at the speed and everything that it's going to go at. And like I said, because of the timer running at kind of a slower rate, it might look a little janky, but we'll see. Okay. It's not moving at all. At least it appears not to be. Try to think. We did set the open rotation, I think. Yes. Right, let's try increasing this to something like 2. All right, so that's at its current speed. We're going to want to increase, so as you can see, it's kind of stuttering. That's between, well, that's due to the timer. So because the timer is running at 0.1 seconds, it is going to kind of like each little skip that it's having is due to that timer. So we're going to increase the, we'll leave that the same for now. We're going to go to 3 and see how that's, if that moving at a faster rate kind of hides the stutter. Because I like to have this run at pretty much as slow of a rate as possible. All right. Yeah, we're gonna have to increase the timer speed. I mean, decrease the time between the runs. So we're gonna do from 0.1 to 0.0. Let's do 3 and see what that looks like. All right, looks a good bit better. I'm gonna change that up to, let's bump it up to 4 for the speed. And I'm gonna jump you down to 0.02, make it a little smoother. And that should be okay. Now we can set it up and do our, what's it called? Our comparison. So if the new rotation is equal to within uh, certain padding of the open rotation, we kill the timer. So new rotation dot equals, and then the rotator we want to compare it to. So open rotation, and then the tolerance. So let's set it to 0.1 for now. Then we're going to pause the timer and do the exact same thing below it, but for closed. Set this to 4. And see what it looks like. That does not look like it's going a full 90 degrees. That would be the only thing. Let's change the tolerance a bit. And increase the speed in which it rotates again. That's neat. That's it. That's a good bit better. We're going to bump this up to 7 and call it. So we can do a kind of an improvement here. Instead of having to continually do a simple check, well, actually, no, we're going to leave that there. I want to try something on the server. So if we are not the server, we're going to run this here. But if we are the server, with it, since we're running dedicated, we're going to make it snap the door open or closed. So if b door open, we're going to set the rotation to open rotation. Otherwise, we're going to set it to the closed rotation. And see what this does with collision. So it does have a little bit of an issue that it's going to be giving us. So we're going to actually change that back to not doing that. And we're just going to leave it like so. Okay, let's triple check. Okay, it's opening and closing pretty smooth. And there shouldn't really be any huge collision issues. And we can set it up to act with locks pretty much in the future. So let's explain what we just did. So before, how we have our toggle door function, we simply toggle the door open slash closed via an on rep. So because this is set up as an on rep and it's replicated, this on rep function that we made is going to run. So we have a timer set up that is currently paused, but becomes unpaused whenever the on rep event fires, meaning it's going to close or open the door. So if the door is closed and we press E on it, it's going to change B door open to true, which means we want it to open. So here we use our interp2 function, which takes in our current rotation and the rotation we want to go to, and we're using the timer to loop through. So it's going to kind of do it in small little skips, so to say. So it's going to rotate a certain degree, rotate a certain degree, rotate a certain degree, and rotate a certain degree, all the way until it equals the open rotation within just this is our tolerance. So it can have like a little bit of leeway. It doesn't have to be 100% perfect. So this is pretty much what gives us, because it's running on a loop, this is what gives us that smooth looking open. And we don't have to do anything like with an animation or anything like that, because we're simply, well, altering the rotation. We're not actually animating the door, so to speak. And once the rotation is within a certain tolerance of the open rotation or the closed rotation, depending on which one we're doing, we're simply going to pause the timer, so nothing else is going to run in here, modifying the door. And that's how you're able to really make it transition and rotate smoothly. Yeah, hopefully that was pretty simple and self-explanatory. And the next one, I think we're going to cover some form of locking slash unlocking. And I don't know, I got to figure out some sort of key system. So I might have a new inventory item being a key. So I will see you then.